You ever hear a story that just sounds impossible? Something that completely breaks your brain when you try to figure it out? Well, that's exactly what we're diving into today. It's a story about human ingenuity on a scale that is just breathtaking. But it's also a bit of a warning, a cautionary tale about what it really costs to solve our planet's biggest problems. Okay, let's get into it.
It all kicks off with this headline from AgriLink. Saudi Arabia reaps record wheat harvest. Now, just stop and think about that for a second. Saudi Arabia, we're talking about a country that is famous for its massive sandy deserts, right? The Rub al Khali, one of the driest, biggest sand deserts in the entire world. So the question is just how? How on earth is that possible? Where is all that water coming from?
And this map right here shows you exactly why that question is so baffling. This shows global water stress, basically how much fresh water is being used versus how much is available. Yellow, that's low stress. Orange, medium. But that deep, angry red, that is very high stress. And look, the entire Arabian Peninsula is just bathed in it. They're living with what scientists call extreme water scarcity. So yeah, a record wheat harvest there, it feels less like an agricultural achievement and more like a magic trick.
But here's the thing. This story is so much bigger than just Saudi Arabia. If you look back at that map, you see that water stress is a huge, critical issue for billions of people. We're talking India, the American Southwest, North Africa, Australia. The challenge of getting enough clean, fresh water is one of the defining struggles of our time. So that magic trick happening in the desert, you better believe the whole world is watching, because a lot of us might need it one day.
So what's the real problem at the heart of all this? We see Earth as this blue marble from space, but that's a bit of an illusion. Get this, a staggering 97.5% of all the water on our planet is saltwater. Of that tiny 2.5% that's freshwater, most of it is locked up in glaciers. So that leaves this minuscule fraction, less than 1% of all fresh water that's actually available for us in lakes and rivers.
And the consequence of that scarcity, well, it's a harsh reality for a lot of people. According to UNESCO studies, 1.2 billion people live without reliable access to clean, safe drinking water. That is almost 1 out of every 6 people on this planet. And that's not just some abstract number. It's immense daily struggle, it's preventable disease. This is the global crisis that's pushing engineers and scientists to look for an answer in that other 97.5%, the ocean.
And that brings us to the solution. If nature isn't going to provide enough fresh water, well then human ingenuity is going to have to manufacture it. This section is all about how we are, quite literally, creating rivers of fresh water straight from the sea.
The technology behind this whole magic trick is called desalination. Now, the concept itself is pretty simple. You take salt water and you run it through a process to remove all the excess salts and minerals to make it drinkable or potable. For centuries, this was a super difficult small-scale thing, but in the last few decades, technology has made it possible on a massive industrial scale. The leading method for this is called reverse osmosis, or RO for short. Think of it like a super advanced coffee filter. You take seawater, you put it under immense pressure, and then you force it against this microscopic filter, a special membrane. It's so fine that only the pure, tiny water molecules can squeeze through. All the bigger salt and mineral molecules, they get left behind. And just like that, you separated fresh water from the sea.
And if you want to see reverse osmosis on a scale that will absolutely blow your mind, you have to look at the Ras Al Khair plant in Saudi Arabia. This thing isn't just a factory, it is a behemoth. It's a combined power and desalination plant that is the largest of its kind anywhere on Earth. This is the engine that's making the desert bloom.
The sheer volume this place puts out is just staggering. Ras Al Khair produces over 1 billion liters of fresh, drinkable water every single day. Let that number sink in for a minute. 1,000 million liters. It's an almost unimaginable amount of water manufactured from the sea every 24 hours.
And to put that number into perspective, 1 billion liters is enough to supply the daily water needs for about 3.5 million people. This one plant provides water for Riyadh, one of the most water-scarce, fastest-growing major cities in the world. So this facility isn't just some engineering marvel, it's a lifeline. It is the reason millions of people can just turn on their taps in the middle of the desert.
I mean, it is hard not to be in awe of this kind of problem solving. If you are fascinated by these deep dives into how technology is shaping our world, go ahead and hit those like and subscribe buttons. Because, just like any story that seems a little too good to be true, there's another side to this one.
Okay, so we've seen the miracle.
We've seen the rivers being manufactured out of thin air, or, well, out of salt water. Now it's time to look at the bill, because creating fresh water on this kind of scale doesn't come for free. There are some hidden and very significant costs.
So on one hand, you have the miracle, right? Abundant, clean drinking water. Agriculture in the desert. It's this powerful, hopeful image. But on the other side, you have the reality. Desalination is an incredibly energy-hungry process. I mean, generating the insane pressure it takes requires enormous amounts of power. And the process creates this really problematic byproduct that has to go somewhere.
Now, it's worth pointing out that RO is just one way to do this. There are also thermal methods like MED and MSF, which basically boil the water to separate it. And as this chart kind of shows, there are trade-offs. RO often gives you the highest volume of water, which is why it's so popular. But all of these large-scale methods, they share the same fundamental problems. They use a ton of energy, and they create a difficult waste product.
And that brings us to the single biggest environmental challenge of desalination, brine. For every liter of fresh water you produce, you're left with a liter or more of what is basically a super concentrated salty sludge. And this stuff isn't just extra salty seawater. It can be warmer than the ocean around it, and it often has chemicals in it from the process used to keep the equipment clean. And the standard practice for dealing with it, just pump it right back into the sea.
And look, the people who build these plants, they are acutely aware of the problem. Here's a quote from Floris Van Straten, a project supervisor for Rasal Care. He says it is crucial that the brine is pumped far enough away so it doesn't get sucked back into the plant. Why? Because if it does, the water they're trying to clean becomes even saltier, making the whole process less efficient and needing even more energy. But this just highlights the bigger issue. Pumping this hypersaline, chemical-laced water into the ocean can have devastating effects on local marine ecosystems. It can create underwater dead zones where very little can survive.
So, here we are with a classic dilemma. A technology that solves a massive human problem, but creates a pretty significant environmental one. But what if we're looking at this the wrong way? What if that waste isn't actually waste at all?
This is where the story takes another really cool turn, moving from a problem to a fascinating opportunity for innovation. So let's ask a new question. What if the brine, the very thing that's causing all the concern, could actually become a valuable resource?
Check this out. This diagram shows a completely different way of thinking. Instead of just dumping the brine, it becomes a resource. First, it's used for aquaculture to raise salt-tolerant fish. Then, the waste from those fish enriches the water, which is then used to irrigate salt-tolerant plants. And those plants, in turn, can be used as food for livestock. It's a closed loop. It turns a wasteful linear process into a circular, productive one.
This kind of thinking, this is what true sustainability is all about. It's about reimagining our processes to create more value, not just less harm. Solutions like this are totally redefining what's possible. And if you want to stay on top of these kinds of breakthroughs, make sure you're subscribed to the channel.
So, where does all of this leave us? We've seen the magic trick, we've peeked behind the curtain to see how it works, and we've discovered the hidden costs and the brilliant solutions to those costs. Let's try and pull it all together and think about the future of our planet's thirst.
So, what are the big takeaways here? First, human ingenuity is just astonishing. We can literally manufacture rivers where there are none. Second, desalination is a powerful tool for sure, but it is not a silver bullet. It's got serious side effects. Third, and this is a big one, every major solution creates its own new complex problems. There are no easy answers. And finally, the path forward really seems to lie in turning those problems, like brine, into opportunities. It's all about closing the loop and turning waste into value.
And that leaves us with one final, massive question, one that goes way beyond just water. How far should we really go in re-engineering our planet to meet our needs? I mean, desalination is basically a planetary scale machine. It's this powerful symbol of our ability to bend nature to our will. But it also forces us to ask about the limits and the consequences of that power. There's no easy answer, but it's a conversation we absolutely need to be having. What do you think? Let us know your thoughts down in the comments. And if you found this explainer valuable, please hit that like button and subscribe for more. Thanks for watching.